the content of the presentation will be like this. So introduction part first, and then complete overview, basic fundamentals, and a simple demo and case study, state of art, some application and evolution in the field. And those who want to check their opportunity for jobs and all, there is also career path also. So the topic start, I will with that introduction of LiDAR. So the full form of LiDAR is light detection and ranging. So light detection and ranging is an optical sensor. So like we have a lot of other sensors like camera, radar. So like that, there is a sensor LiDAR. So which works on like by transferring the laser beam from transmitter and get back that laser beam from that reflected object to the reflector. And the LiDAR usually it work on UV, infrared, and visible light range. So it is a narrow laser beam. So that's what the introduction parts, and like how it works better than radar, and because radar and LiDAR have same functionalities almost, but I will explain how it is better in the previous slides and next slides. So next slide is why LiDAR. So I think in current industry, everybody have know about some self-driving cars, and they are using some LiDAR and camera and radar sensors. But mostly I will focus here on why LiDAR they are using. So LiDAR actually give that much more accurate depth information. So like you want to get like a LiDAR sensor is there in your car, and you wanted to detect a pedestrian or a truck or a car in front of that self-driving car. So, and you want a sensor which can give the best distance information. So in that case, LiDAR is the best possible sensor, because whatever the light range it is using, so that is like almost having a spectrum of UV rays and ultraviolet. So it didn't affect by like atmospheric disturbance and all. So it will directly and straightforward way, it will go hit the target and reflect back. So that's how it get the distance information. I will explain the distance formula in the next slides. And the precision definitely it's having much precise, because it is not reflected back with the object or atmospheric glitches. So that's why it is much precise. But in the case of radar, if we will compare, so radar also giving the distance information, but radar use the sound wave and high frequency waves that usually get distracted and reflected by atmospheric like medium and some particles and all. So that's why it cannot give the precise in the case of radar. But LiDAR, because the light pulse, it didn't get deflected much. So that's why it giving more precise information. So now the next is that LiDAR components. What all components are there in LiDAR? So first is that laser pulse emitter kind of things. So it will emit, and the scanner. So like the scanner, if you see that if you had seen any self-driving car, there is a like a Gaussian knob kind of things at the top of the car, and it always rotates. So scanner is like it, if you have like a rotating kind of mechanism in your LiDAR, so there it's helpful. Photo detector is for like receiving the light whatever the transmitter is sending. So the photo detector will detect and then tell the further information about the object and depth. IOMU is that alternate and is not necessary or compulsory component for LiDAR, but in case of self-driving car, it is definitely like major component IOMU. So it's like for measuring that roll pitch on. And now the working principle. So the working principle is like that. So as I explained in the previous slide, laser, scanner, photo detector, IMU system. So I will start like that in the same way. Like, so first laser emitter is there. So what it used to do? So emitter will emit like a bunch of pulses of light. So we usually had seen in our childhood time, like we play with a laser torch, which have very high pulse emit, and we used to play in the night. So like the same way that LiDAR also work, but in industrial LiDAR, we used to make an array of that kind of LiDAR. So each array will emit the LiDAR pulse, like a kind of light pulse, and then this pulse is transmitted, reflected back to the receiver. So when we are transferring our light rays, like UV light or infrared light, whatever bandwidth is there. So after hitting the object, like the car in front of you or any object through which the laser beam cannot pass. So some light will reflect back, some light will get transferred, some light will be like get diverged in the medium itself, but we have to only focus on the what reflect back. So we collect after this hitting the object, there is a photo detector. So we collect on the photo detector whatever reflected beam is coming, and we calculate. The next step is measuring the travel time of the pulse. So this is what the LiDAR components used to do inside the LiDAR. So the next is how LiDAR is measuring the distance. So as I explained, like there is a light beam which emit from the array of that like sensor emitter, and then like a detector is there which receive, and there is a time which used to calculate. So I will explain with this very basic formula. So we all know that velocity is equal to distance upon time. So in our case, because we are using the laser having that velocity of light, so that is c. Everybody know that c is equal to the speed of light, and then we want to measure the distance. Is our sensor want to measure the distance? So what we have to like what all unknown parameters will be for us, that is time t. So let us suppose in this picture I had set up my LiDAR on this aeroplane, and it transferring the beams towards the earth, and I wanted to measure what is the depth of that tree, or what is the depth of that earth, what all the depth related information is there. So because I have already this parameter speed of light, and what I need to know that time. So as I explained in that previous slides, that there is a two components, specifically like a transmitter and receiver. So transmitter used to emit the laser beams, and receiver used to receive it. So to measure the distance, transmitter will transmit that beam and receiver will receive it. And what the IMU, like what the CPU or that other processing unit will do, it will measure the time. So when that transmitter had transmitted that beam, and when the receiver had received that beam, what is the time in between that? So to measure the distance, because the light is covering going and coming back, so it's like a 2 times of the distance. So we have to do t by 2 in our case to measure the distance only. So in the LiDAR, so what processing unit used to do, it will calculate the distance by this formula c is equal to t by 2, whatever t time taken by LiDAR from emitter to reaching at the ground. So this is very simple formula they had used. So now let's go for the what all LiDAR platform, like where are we using this LiDAR sensors for what all purpose. So for now I will explain like we are using like for aerial purpose, like aerial systems, or like aeroplane, like helicopter or drone, and then satellite. So the initial stage of that LiDAR, or initial usage of LiDAR, was uh, satellite. So usually like we used to see the things from the space, like the terrestrial information and like the forest or some other informations. So we used in that mostly in the case of satellite. And then terrestrial, definitely everybody know where we are using on the terrestrial, like on ground, like if you are developing any rover, and mostly if you are seeing that self-driving car, and there is currently one uh, so there is a robo dog came. So in that also, mostly for what estimation of path and mapping purpose, they are using lidar. So I will explain what all applications are there of lidar in the different field and sectors. So as you can see, so first I will explain in agriculture sector. So in agriculture sector, let us suppose you have a drone, and you have collected a data of forest or field, like from the sky aerial view. And after collecting that, you can get the idea of where the crops are missing, and which region are like infected by some like insects or something, what all the slope information. So accordingly we can put fertilizer, water, or anything like that, whatever can help our agriculture or crops, anything. Then next application is the biology and conservation. So in the case of like I explained the agriculture, in the case of forest also, we can use lidar, either aerial or on ground. So we can detect what all the trees are there, what all how much the dense the tree is it, and what the height and all things. And we can collect the information, and we can make sure that okay, that in the forest everything is if it is going fine or not. The same way we can use the lidar in industry purpose. So currently so many projects are going on. So especially I will tell about this Indian Railway had started some project related to lidar. So they have wanted to allocate the land, and they want to check and like on site what is if that land is fit for railway track, or like what all the issues will come. So first they used to scan that uh, area with the lidar and get the depth information. So then after that they used to proceed. So like that, the other like industry and energy sectors, they use lidar for their own purpose and benefits. Like that, the other applications are the wind farm optimization. So especially in the case of the wind turbine rotor, so it usually with the using of lidar, with the help of lidar, it optimize the blade and the directions, because air like the air have some particles, everybody know. So when we put the lidar, so there are different kind of lidar, so like flash lidar and normal lidar or solid state lidar. So it can even detect what is the wind flow, which direction is it, because the laser pulse can hit the air particles and come back and can give the information of like the what is the air particles, how dense it is. So accordingly, that wind turbines can optimize their blades and direction also. So in that sector, it's helpful. Law enforcement, currently, I have not seen much in India, but in US and UK, the police usually use, even in India also, like metro city, they are using also. So they are using the gun, so lidar gun. So it's a kind of lidar sensor is there inside, and to measure and to get the speed of the vehicle. So what it used to do, they target that laser gun towards the vehicle, and the laser pulse we used to go hit on the vehicle and come back, and it will can give the velocity of the vehicle and then distance, and then so that is helpful for law enforcement, that application. Then mining, and this mining sector is currently in a very trending way. So what people used to do, they used to fix lidar on the top of the rover, or some drone, and then send it inside the mining sector, because it's very hazardous place for going for humans, because there is so many accidents used to happen. So after going inside, that lidar can map what all wage inside that caves are there. So after mapping, it can come back and give all the detailed information, what is the way, what all possible cracks are there. It can give all the detailed information, so that after that human can go later for their. And then physics and astronomy. So definitely in that cases, like I had told, satellite, or even in the case of like ISRO had launched so many like satellites for detecting the atmosphere, especially in the case of cloud. So when you are getting the information or news about that tomorrow will be rain. So what lidar is doing in that field, that there is a lidar on the satellites, and it will uh, detect where the cloud dense is more and what direction it is moving. So that's how, after calculating all, we can get the idea, okay, the cloud will be at this place after that time. So in that sector, there is an application also. And very current and new one application is in Apple Pro 12 phone. So there is a, I will mark. So this is the lidar in the Apple Pro. So what it's doing is like just for mapping purpose, and you can do all the like funny stuff also, like but the major application of this lidar application is getting the facial information. So when you are clicking any picture from the camera, you will get only like what is the color of the face, where the eyes is there, all of those like spatial information. But because Apple is using this lidar, it will tell it, and it will get the depth information of each of your like facial part. So what is the like depth of your nose, or like cheek and ears, and so it's like it's help to get much better features for recognition of your face. That's why it is much more secure than only using the camera. So that was the intelligent way of detecting the faces. So that's why Apple is always more secure and better in performance. So there is another application like this. Now I will come to state of art some application like Lidar Speed Gun. So currently this application is in trending, and so many people are working on this sector also, and so many work had already done also. So Lidar Speed Gun, as I told, there is a like a device which can measure the speed of the vehicle, and in that case, like police can like summon anyone or accordingly. But in others, this lidar speed gun, we can use in other sectors also. So like in a physics laboratory, or like astronomy sectors and all, the same things we can, same concept we can use. But mostly like lidar speed gun we use for like enforcement purpose, and getting the speed of the vehicle. Next is a self-driving car. So because this presentation I started with the lidar, and currently most of the like work whatever we are seeing nowadays, technology is going, improvement is going on. So most of the application we are seeing in self-driving car. And as per my experience, because I had worked on self-driving car, some lidar sensor part, so I think I will give a little more detailed explanation about this application.